And I swear it's blowing out cold air. But here we go. D. Nice and loud. Negative root 2 over 2. Perfect. E. Gus. Negative 1/2. Super. Enzo. F. Negative 1/2, he says. G. Louisa. Negative 1. Perfect. H. Frank. Negative 1. Ben. I.
Negative 1/2.
Perfect. Bennett. J.
1/2.
1/2. And K. Scout.
Sine 0, 1, pi 0.
Where's 0? 0's out here, right? What are the coordinates of that point? 1, comma, 0. And we want the sign, which is y, so the answer is 0. Okay? Is that all right with everybody? Okay. And finally, Cole, you got L?
I got 0 for that one.
0, absolutely, because we're straight up there, and X is 0. Very, very good. Now, before we go any further, I'm going to put a couple up here, and I'd like you to kind of look at it, digest it, and see if you can figure it out. So we're going to do cosine 8 pi over 3, and we're going to do tangent 15 pi over 4. So, I'd like some volunteers to come up, maybe, and give this a shot. Figure out what you're supposed to do here. I know the first thing you're thinking is, wait, those aren't even on my circle. But you can do it, right? So you guys at your seats, don't let the guys do it alone. You work along with them. Show us your thought process. I just need to be able to pick it up.
It's cosine, so it's Ex.7.
Like I know it.
Go ahead.
Oh, my thought process was.
So what is the answer? So, did you figure out how to handle this? Both of those angles are more than a revolution, right? So we're going to get rid of that extra revolution. So in both cases, we can subtract out a 2 pi, or in Kellen's problem, original problem, he's going to take out 6/3. And so the angle he's really dealing with is 2 pi over 3, which is on our unit circle. We know exactly 2 pi over 3 has an x coordinate of negative 1/2.
Yeah, no,
So he's exactly right. And then for 15 pi over 4, that's more than a revolution, so we'll take out 8/4. And so that's why we're looking at an angle that is 7/4 pi, which is where on my unit circle, 7 pi over 4 is right here. And what do I know about the coordinates? Now that's a pi over 4 angle, so they're the same. And the second one's negative, would you agree? So cosine of 7 pi over 4 is root 2 over 2. Sine is negative root 2 over 2. But I want tangent. What's tangent? Y over x. Sine over cosine. So actually the answer to the problem is negative 1. Negative 1. Okay? We can find the sines and cosines of any special angle. Obviously, it has to be a pi over 4, pi over 6, pi over 3. But otherwise, we can do all those, no matter how big or small they are. Okay, let's look at, first I wanted to look at a homework that I turned back. Okay. The one I wanted to look at was 3-2. Problem 2. Now, a couple of you came in and got some help to work through this. And some of you bravely tried it on your own, which is absolutely awesome. But, and some of you were successful and some of you weren't so successful. So, y equals, here's some circle. Some circle. Y equals negative 4x. What does that line look like? It has a slope of negative 4, which means down 4 and over 1, or up 4 and over 1. So would you agree that the line looks something like this? And if I build a triangle in there, this side could be negative 4 and this side could be 1. Now, could those sides be other things? Yes, but they're in that ratio, correct? So I could have negative 8 and 2. I could have negative 2 and 1/2, whatever. But they have to be in that ratio. Got it? Okay, makes sense? Now, if I use negative 4 and 1, then what would the radius of my circle be? If those are the points I choose to use, right, over 1 down 4, then this would be what? Root 17. Remember, your radius is always positive when you create the picture. Now, you'll be looking at some situations where you might be given a negative radius and you have to deal with it. But when you're doing the problem, Pythagorean theorem, that radius is always going to be positive. Okay, so this point right here is 1 negative 4, and there's my radius. It says, what's the cosine? Well, you guys, what's the definition of cosine? Cosine is x over r. So it's 1 over root 17 or root 17 over 17. I'm still not clear on the rules for rationalizing. Okay? Sine. I'm not going to mark it wrong anyway. But be prepared to rationalize if somebody ever answers my question. I mean, somebody who knows. So sine would be negative 4 over root 17. And I need tangent. What's the tangent? Which is the slope of the line. Because, is it slope y over x? So tangent and slope are tied together. All right, while we're here, I'll do one more problem. I want to save the rest of the questions for when we have a review day. But on 3-1 or 3-2, anybody have another question? Anybody?
4C.
On
3-1.
3-1. 3-1. 4C. Okay, so what points am I looking at here? E and F, right? So I'm looking at points E and F, and I want to describe the rate of change and explain explain. So in other words, I want to be as thorough as I possibly can. So, what can I tell going from E to F? Well, first of all, would you say that that rate of change is the rate of change, positive or negative? Negative. Why is the rate of change negative? Because the slope is negative. Okay, so the rate of change is negative. Is it increasing or decreasing? Decreasing because it is concave down. Yep, yep. All right, okay, we'll put those away. We'll come back and do some more of that. But I want to finish a couple more things. These are not necessarily in your notes, so I'm adding in. So I don't know if you can squeeze it on those notes somewhere, or if you want to put it in your sheet paper. But now we're going to use the unit circle backwards, and we haven't done much of this, and it's really, really important. So I want to do it. First thing I'm going to do is restrict my domain from 0 to 2 pi. Now, what does that do for me? Well, that tells me that whatever I'm doing it in one revolution. Does that make sense to you? And why is that beneficial? Well, remember, every angle has infinitely many coterminal angles. So if I'm only in one revolution, then I don't have to worry about what we were worrying about earlier when the boys came up to the board. So here's what I want you to think about. Try it without your unit circle if you can. I have an angle out there, and its cosine is negative √3 over 2. Can you tell me what that angle has to be? Keep in mind, you're going all the way around your circle. Okay, so what do you think? Cosine is x. Think about your unit circle. Oh, radian, an angle. Yeah. Huh? So, well, 210 would be a degree. I want that in radians. I want it in a radian measure, so not 210 degrees, but maybe the equivalent of that. Cool?
120 and 240.
Okay, now again, those are degrees. We need radians. So like pi over 6, pi over 3, 8 pi over what?
2 pi over 3 and then 5 pi
So
over
2 pi over 3 and
4 pi.
4 pi over 3. All right. Here's what goes through my mind. And I'm going to check, because I don't have that whole thing memorized. I'm going to check. What goes through my mind is I've got these 3 points in quadrant 1. This is my pi over 6, pi over 2, pi over 3. I need the first coordinate to be √3 over 2. That happens right here. This is √3 over 2, comma 1/2. So this is the angle that I want. It's a pi over 6, for sure. Would you agree with me? Now, here's the next thing I'm thinking about. It's negative. Well, cosine is x. Where is x negative? Here and here? So I need the pi over 6's here and here. So what should my answers be? You're in the right quadrants. Check it on me. What's the pi over 6 over here? 5 pi over 6 and 7 pi over 6. Does that make sense? Which would be 150 and 210 if you were in degrees. Absolutely. All right, let's try another one. There's an angle out there somewhere, and its tangent is 1 over √3. So say 1? Because what's tangent? Y over X? And won't that be 1 over root 3? Are you with me, folks? So one answer is pi over 6. Where will the other answer be? Is there any other place that tangent will be positive? Alex? 7 pi over 6. Why is tangent positive at 7 pi over 6? Because x and y are both negative. All right, let's try another one. Sine theta equals root 3 over 2. Here's what's going through my head. I got that one. I know it's not that one because that's where they match, right? So this point is 1/2 root 3 over 2.
5 or 3.
Does that angle have a sine of root 3 over 2? So one answer is pi over 3. That's this angle right here. Where else? 2 pi over 3. Because sine is y and y is positive here. So the other answer is 2 pi over 3. It is not hard, but there's a lot to keep track of. A lot to keep track of. All right, let me give you 3 to try on your own. I've done 3. I'm going to give you 3 to try right now on your own. Because there's a whole page of this in your homework. Oh, same directions and go once around. If we don't go just once around, then we can go more than once around. And so we have pi over 6, but we would also have 13 pi over 6 and negative 11 pi over 6. I mean, there would be just zillions and zillions. They would just keep going. So this kind of hold this in. All right, let's do a tangent. Tangent is negative 1. Oh, we may have already done that. And cosine is negative root 2 over 2. And sine is negative. All right, see if you can come up with those. You think you got one? Go ahead and come on up, put it on the board for us. Each of these should have 2 answers. The only time these problems might not have 2 answers is if you're an angle that's an axis, like if you're at pi over 2. Sometimes those only have 1. Sometimes they have 2, but sometimes they have only 1. These will always have 2 answers. These kind. I'm gonna pick on Gabby for a minute. I know, I love your thought process. First thing she did, I don't know if you're right or not, but I love what you did. She looked at the root 2 over 2, oops, sorry, And she says, okay, that's a pi over 4. So she just set up two fractions and put a 4 in the denominator, because that root 2 over 2, she knew was some version of pi over 4. And then, I don't know what went through her mind, but she said, x is negative. So think of your coordinate plane, where is x negative? In 2 and 3 quadrants. So she picked the pi over 4 angles in quadrants 2 and 3. So you did get the right answer, Gabby. Those are absolutely correct. This one we had, I think we did some version of it, maybe not, I can't remember. But if the tangent is 1, what does that tell me about y and x? They're the same. And that happens at this angle, right? Pi over 4. So my answer again is going to be some version of pi over 4. But since that's a negative 1, I need the signs to be different. So that happens in quadrant 2 and 4. Perfect. Beautiful. You did a lot of messing around over here. You finally good with what you got?
Yeah, I did
Okay.
the tangent at first.
Okay. So he said the sine is 1/2. So again, because I don't have everything memorized, I'm thinking of my unit circle. I know this point is root 3 over 2 comma 1/2. And actually, that's the one I want, because I want the sine to be half. So what angle is that? This is going to be a pi over 6, but it has to be negative, which means y has to be negative, which means I'm picking the pi over 6 that's in quadrant 3 or 4. Beautifully done. Beautifully done. All right, turn to page 16 of your notes. Number 1 should be easy. We practice this ad nauseum. Now let's practice again. Do number 1 with your partner, check answers. Make sure you're right. And then we'll move on to number 2, which is more interesting. Perfect. You guys done?
I'm looking for it.
Let's see. Mark and Ella, you guys haven't shared today. Yeah, are you done with number 1 yet?
No, I'm still gonna see it.
Okay. Keep going. I'm gonna get some answers. If you're done with number 1 while we're waiting to get some answers here, go ahead and start thinking about number 2. Well, right now, we're waiting for answers. Okay, we're on page 16. Make sure you're on page 16. You guys got something back there? Go ahead. Go ahead. What's the worst that can happen?
Alright, we got negative 1/2.
All right, shh, we're getting answers for number one. A was negative 1/2, he says, okay?
And then B, negative root 2 over 2. And then C, negative 1 over root 3. And then D, negative 1.
I agree. I don't know what you guys are worried about. You did great. We okay? Anybody have a question? C is, he said negative 1 over root 3. I put negative root 3 over 3. It's the same thing. Now, that last one, 7 pi, did everybody take out 6 pi? Because that would be 3 revolutions. And so pi, right over there, negative 1, perfect. All right, number 2. Anybody find? I think we can talk about this problem for a very long time. We don't need to. But there's lots of things that make it different. So, I mean, the most obvious thing is 3 of them are sines and 1 is a cosine. Okay, so there's one way of, saying you don't belong. Did anybody come up with a different reason that one of them might not belong?
One of them's negative.
What?
One of them's negative.
Okay, one of the angles is negative. So 3 of the original angles in the problem are positive, 1 is negative, okay. Remember, Cole, negative just means you go this way on your circle.
I mean, it's different.
Yeah, but it makes it different, you're right. Ben?
3 of the radians are negative, not responsible.
Yeah, that's what Cole just said, yeah, you've got 3 positive angles and 1 negative, yeah. Negative pi over 3.
No, like, Jesus,
Oh, one of the answers. Okay, Ben says the answers, the fractions, 3 of them are negative and 1's positive. 3 of them are also root 3 over 2's of some sort, and the other ones are 1/2. Lots of ways to talk about it being different. The idea is you're supposed to know that the sine of 2 pi over 3 is root 3 over 2. And the cosine of 5 pi over 6 is negative root 3 over 2. The sine of negative pi over 3 is negative root 3 over 2. And the sine of 11 pi over 6 is 1/2. Negative 1/2. All right, now number 3. This is the one. Let's look at number 3. So we have 3 concentric circles. One at a time. And here's point, the angle is 5 pi over 3. So here's my angle. And this is point A. And it is on the circle with a radius of 1. So isn't this my unit circle? At 5 pi over 3, what are my x and y on the unit circle?
1/2, negative root 3.
1/2 negative root 3 over 2. Is everybody okay with that? So the coordinates at point A are right there. That means that the cosine of 5 pi over 3 is 1/2, and the sine of 5 pi over 3 is root 3 over 2 negative. Okay, now let's go out. Now it's going to have a radius of 2. So now R is 2. And I need to find this point right here, which is point B. Multiply them all by 2, bingo! Because what did we talk about yesterday? X equals R times cosine, remember we talked about that yesterday? I mean, X equals R cosine. So what is my X going to be? It's going to be my cosine times 2. So that's 1. And my Y is going to be my sine, so that's going to be negative root 3. So then we draw one more circle. then this time, is the radius 3, this time times them by 3. So this will be 3 halves and negative 3 root 3 over 2. X is r times cosine, and y is r times sine. Okay. Tell you what, before we start this review, let's answer all the rest of your homework questions. I didn't think we had this much time. Who has another homework question from 3.1 or 3.2? I'm assigning 3.3 today, so that will be due on Monday, I guess. 3.1, number 3. Number 3. 3.1. So I'll go back to problem number 1. Find all the values of x so that y is 3. Okay, so I'm going back to problem number 1, and I want to find x, so my y is 3. That's what the problem said. Okay, so look at the picture. Where is the y? Where is the y 3? What are some places on the pictures of x values where the y is 3? That's 2. Are there any others? 8. Are there any others? Well, wait. 14 isn't, well, I guess it is kind of on the graph. Would there be any more that aren't on the graph? Yeah, what would the next one be? 20. So you have observed that the period of the thing is 6. That means, so that's y. When you put in 2, you get 3. And when you put in 8, you get 3. And so on and so on and so on. Now, you can't possibly keep listing. You'll be as old as me and you still won't be done, right? So we have to have another way of expressing that without individually listing each number. So, isn't 8 2 plus 6? And isn't 14 2 plus 2 sixes? So our x's are simply 2 plus multiple of 6. So 1 6, 2 6, negative, we can go backwards, negative 1 6, negative 2 6s. So we'll say k is a whole. Actually, when we say that, we gotta put plus or minus. We could say this. K is an integer. Either one of those is perfectly okay. You need to be able to go backwards. So you need a negative. If you use integers, it's built in, because integers include negatives. If you use wholes, you have to put the plus or minus. Does that make sense? All right, who else? Anybody else? Are we out of questions? Declan? 3.2, number 1. We have an angle in standard position, so that means it starts here, and its terminal side is over here at negative 3, 4. So this side is negative 3 and this side is 4. I'm supposed to be finding sine and cosine. Just assign a tangent. Well, sine is y over r. So my y is 4. What's my r? I don't know, but I can use a Pythagorean theorem to figure it out. So that's an easy one, it's 5. So sine is 4/5. And tangent, I don't need that for, because tangent is y over x. So negative 4/5.
Can you do 3.2 number 5?
In the unit circle, the point, okay, so the point we're talking about is down in quadrant 3. And, Alex, since it's negative 1/2, negative Do you have any idea what that angle is?
Is it 5 or 4/3?
4/3 pi. Exactly. Okay. Now, we're going to do what? Reflect it across the y-axis onto point M. So we're going to reflect this across the y-axis. So we're just going to fold it across the y-axis. And it's going to look like this. Does that make sense to you? So this angle and this angle are going to be the same, okay? So what would be the this is point M. What would be the coordinates at that point? Now remember, this one went left a half and down to 3/2. This one's gonna have to go right a half and down to 3/2. So what do I want to do? The sine, I'm on the unit circle. So the sine is that, the cosine is that, and the tangent is that over that, which would be just -3/3. All right, anybody else?
Can you do 3.1,
3.1, find the value of, okay, so am I in the right problem? Okay, so we just talked about the period of this thing is 6. That means every 6 it repeats. So f of 19, working backwards, would be the same as f of 13, or f of 7, or f of 1. I mean, all those things would be the same. Would you agree with that? So I'm just going to use 1. What's f of 1? Well, f of 1 is a little bit higher than 2. So on the answer key, I said it's about 2.2. I didn't mark it wrong if you said 2, some of you said 2.3. I marked it wrong if you said 3 or -1, you know, something weird like that. But it's about 2. It's a little bit more than 2. Does that make sense? Okay, so what about -32? Well, remember, every 6 it repeats. So you don't need to write all this out, but that means negative, it's the same as -26, -20, -14, -8, -2, and 4. Now there's a shorter way to get to 4 than what I just did, but does that make sense to you? As we go through every 6, it's going to be the same. So what's f of 4? F of 4 is 2. Remember, when we say f of 4, we mean what is the y value that goes with that x? So x is 4, what is that y? 200, okay, I am not doing this with 200. Okay? What do I need to know? I need to know how many groups of 6 are in there, right? So what's 200 divided by 6? Oh, you could do it in smaller increments. I'm gonna go ahead and divide it. So it looks like 33 with a remainder of 2. Now what does that mean? That means I have 33 full periods, and then I have 2 units left over, so it's gonna be the same as f of 2, and f of 2 is 3. Does that make sense? Delilah? 3.12b, g of 12. Well, the first thing I have to do is find g of 12. It's not in my chart, so coincidentally, the period's 6. So g of 12 will, I'm doing just this part now, so g of 12 will be the same as g of 6. Do I have that in my chart? Yes, it's 1. So this is 1, right here, that's one. So now I have to find G of one. Oh, and that's in my chart. So the answer to the question is two. You good? All right, I'm gonna stop there. We're gonna start reviewing next time. Your homework is, if you got homework to do, you got 4 minutes, you can work on the homework. You can gather up and visit with each other, but nobody gets out of your seat.